All right, guys and gals, this is Chapter 9, Section 3. We're looking at rotations. They should be fairly straightforward, you would think. Unfortunately, a lot of people find these to be a little bit challenging, so I'm going to try and show you some ways to make them less so. One thing that you will need for what we're going to do is you will want a protractor. I'm going to show you how to do these kind of paper pencil without the coordinate grid, and then we'll take a look at it with the coordinate grid as well. You might also want your compass. Some people like using those as well when we do these, but you definitely want a protractor because we're going to be measuring out those angles, whatever they may be. So take a look. Let's start off with what is a rotation, and then we'll go from there. So a rotation is a transformation that turns every point of a pre-image, so for example, this blue pre-image, through a specified angle and direction about a fixed point. So in other words, here's our fixed point. All right, we call it the center of rotation, in this case R. We're going to take A, B, C, D, and we're going to rotate it around. So all of the points are going to travel the same angle and the same direction relative to that fixed point. All right, and the angle is called the angle of rotation. So let me show you something here. Take your protractor, and I'm going to use a smaller one. If you've got a larger one, it's fine, but smaller ones will work here perhaps a little bit better. What I'm going to do is I'm going to draw a line from R to D. All right, so let's do that real quick. We'll just use our straight edge here from R to D. Okay. And notice that distance is going to be maintained from D to D prime. So let's draw that other line there from D prime to R. Okay. And let's practice measuring an angle. All right. So what you do is on your protractor, you should have either a center mark like I do, or in some cases, there might be a small hole in the center that lines up with the zeros and 180s. And that's going to be where we put the vertex, right? It's right there in that hole or right there at that mark. So I'm going to line it up. For me, it's the bottom edge of my protractor. For others, let me show you one here. This one has a hole at the bottom, and then this line is what you'll line up that angle with, that bottom edge of your angle. So for this protractor, I would line it up this way, all right? For my protractor, I'm going to line it up this way. Now notice, my lines here are too small for me to be able to read. So if you need to extend them, that's fine. And I'm going to do that now. So we'll extend them a little bit. Try not to draw your lines and things that we do too dark, just because they're not ultimately what we're looking for. We ultimately want the figure rotated, not these auxiliary lines that we're drawing. So we'll line it up. So my vertex here at my point or at the hole, my edge of my angle there on the bottom or on that line. And if we notice, we've got an angle here of about 60 degrees. That's our angle of rotation, all of these. So if I measured from A to A prime or from B to B prime, all of them will have that same roughly 60 degrees of rotation. Notice that's our angle. The direction that we're going in this case is a left-hand turn, so that's counterclockwise. So if I were to describe this rotation, I would say that we're turning counterclockwise, 60 degrees, about point R. So we need to know all those things. We need to know direction, clockwise versus counterclockwise. We need to know our angle, right? In this case, about 60 degrees. And then we need to know the center of rotation, in this case, R. One thing that you do need to know, we always assume a counterclockwise rotation unless we're told otherwise. So always that left-hand turn is what we're going to assume. So if I ask you to rotate something, say 60 degrees, but I don't specify direction, know that counterclockwise is the way we'll go. All right, so let's try one of these, not one that's already given to us, so that you can see how this works. All right, so we've got a pentagon here. We're going to rotate it around point R. So this is going to be our center point. It's not going to move. We're going to rotate it 110 degrees. And notice this time it did specify we're going to go clockwise. So clockwise is a right-hand turn. All right, so the way the hands on a clock will move. So here's what we're going to do first. I'm going to start off with point P just because it's at the top. You can start wherever you'd like. And what I'm going to do is I'm going to draw a line from P through R, or from R rather through P, if I could read. There we go. Something about like that. And what I'm going to do is I'm going to then measure out that clockwise fashion. So I'm going to start from here and go to the right, that clockwise fashion, 110 degrees. So let's get our protractor on here. Line it up. Again, we want to be as accurate as we can. So notice when we count, this is not the 110 degree mark. Right? Notice that angle would only be an acute angle. So that's not what we're looking at here. Right? Our 110 that we're wanting, if I can keep this still, the 110 that we are wanting is all the way over here. So I'm going to count 10, 20, 30, 40, and so on, all the way out to here. There's 110. Okay? So let me draw that in. And again, try not to draw these lines too dark on your page. I'm going to draw them kind of dark so that way you can see it on the image here, the video. So there's my 110-degree angle. This is where our compass comes in. So that way you're not having to do so much measurement. What we'll do is we'll take the metal point of our compass. We'll put it on the point of rotation. We'll come over here to point P. We'll get that distance. We'll come over. And then we will simply make an intersection. And that's where P prime will be located. So I'm going to make that dot a little bit bigger. And we'll name it P prime. So that's P rotated 110 degrees around point R clockwise. And then we just do the same thing over and over and over again for each of the other points. So for example, let's do Q next. We'll go around that way. Let's see, line this up. I can't tell if U and Q line up with R exactly or not. It's awful close. We'll go with it. We'll say they do. Yeah, looks like those two line up exactly with R there, so that'll make that easy. So we can use the same line for both U and Q. So that'll be nice. All right, so let's draw our angle in. So again, I'm going to line up that center dot, bottom edge. We'll count 110. So again, 10, 20, 30, 40 in that clockwise fashion over here to 110. So it's right there. All right, let's make our mark. There we are. So again, this is going to rotate in this direction. So it should be over in here somewhere. Let's grab our compass. I'm going to get my U distance first since we're already kind of large there. All right, there it is. So we take that distance. We come over to our line, make a mark. I'm going to go ahead and label it so I don't forget what that is. So right here is U prime. And then let's do it again. Notice Q's on that same line, so we can do that. If Q wasn't on the same line, then obviously we would need to draw another set of angles out. Oh, let's make this smaller. Here we go. So right there at Q. Excellent. So we'll come over here, make our mark. And there is Q prime. Now, if you don't have a compass or don't want to use a compass, then what you would need to do is grab a protractor or ruler that you could actually measure with. And what you could do is measure the distance from Q to P and then do that same measurement to get from, or not Q to P, from Q to R rather, and then measure that same distance from R to your new Q prime. Okay. So let's do it again. We got to do it for S and T. I'll do it for S next. Don't want to use that one. That's too big. Here we go. So from R to S, and again, we'll kind of extend that out there. Excellent. We'll line it up. We want to be as accurate as we can. So again, 10, 20, 30, all the way around here to 110. So we'll put our mark there. Draw it in. Excellent. So this will get us S. So let's line it up. There it is. And we'll circle around. There we go. That gets us to S prime. And then we just need our last one there at Q. So we'll draw our line in. There we go. Line it up. Get our 110-degree angle. So in this case, it'll be over here. Draw it in. There we go. Let's grab our compass. We'll go from R to T. There we go. Take that same measure on our new line. Draw it in. There we go. And there is T prime. So now what we get to do is play connect the dots. So for example, from T to S, S to Q, P to Q, there we go, U to P, and finally U to T. There we go. So notice there's a little bit of a distortion there. It's not exactly perfect, but again, look at the tools we're using. They're not exactly state of the art. But again, it should be fairly close. So we should have roughly the same size, same shape, just rotated around. I'm going to make this P prime a little more distinct. There we go. 110 degrees clockwise. We'll spend some time in class practicing these, so I strongly recommend that you bring your compass and your protractor with you. That way, as we practice these, you've got the tools that you need with you to get that done. All right. The other way that we're going to do our rotations is with the coordinate grid. Now, I like doing those better for no other reason than there's not near as much work to do. So let's take a look at it. There are 3 different rotations that we're going to look at. And again, all of these assume Now let me grab a highlighter here. They all assume a counterclockwise rotation. Now, let's look at each one. We'll look at the coordinate notations, how they work, what they mean, and then we'll do one. So take a look, a 90-degree rotation, again, assuming counterclockwise. What we do is we switch the original x and y. So in this case, our original is 5 and 2. We switch the x and y's position. So in this case, the 5 would go second, the 2 would go first. And then whatever that original y was, we make it opposite. In other words, we multiply it by a -1. So when you read this, we could say our x and y maps onto opposite yx. And the reason I say opposite is if your original coordinate was negative, by multiplying it by -1, you'd make it positive. So again, that's why I have people read it that way. For 180-degree rotations, again, it really doesn't matter direction, whether I rotate this way or this way, we'd end up in the same position. But the 180-degree rotation is simple. We simply keep the x's and y's in their original positions. So notice the 5's first here and the 5 is first here, 2 is second, 2 is second. The only difference is we're going to multiply both the x and the y coordinate by that -1. So in other words, we would read it as our original coordinates here at x, y maps onto opposite x, opposite y. And that's going to let us go that full 180. Notice this also is the same coordinate notation for a mirror image through the origin. All right, and notice for all of these, they are centered at the origin. So that's that point of rotation. The last one is a 270-degree rotation, counterclockwise. Again, we still trade the x's and y's, but notice this time it's x that becomes opposite instead of that y value. Now, notice all of these deal with counterclockwise. If you want the clockwise counterparts, take a look. This is 90 degrees counterclockwise. We could also view this as 270 degrees clockwise. In other words, instead of going to the left just 90 degrees, I could go to the right 90, 180, 270. So heads up. Down here, it's the same way. Instead of going 270 counterclockwise, we could go just 90 degrees clockwise. So notice you've got 90-degree counterclockwise or 270 clockwise is the same point. 270 degrees counterclockwise or 90 degrees clockwise, again, same point. And then for 180, it really doesn't matter. Clockwise versus counterclockwise, whether I go left or go right, doesn't matter. We end up in the same point. So let's use this coordinate notation. We'll try one here. That way you can see it. And again, in class today, folks, we'll spend a lot of time practicing both methods. So if you're struggling with, say, the coordinate plane, or if you're struggling with your compass and protractor, we'll deal with both. All right, so let's get the original points down first. So we've got P at 1, 1. So that's right here, point P. And then Q is at 1, 2, 3, 4, 1, 2, 3, 4, 5. So there's Q. And then R is at 1, 2, 3, 4, 5, 1. So right there, there is R. All right. And we'll grab a straight edge here. I've got it somewhere. And we'll play connected dots. Again, we try to keep them as nice and neat as we can. Oh, that point P kind of got in the way there, didn't it? Oh, well, it'll be fine. That'll work. So there we go. We're going to graph it with a 90-degree rotation about the origin. And notice it didn't say direction, so we're going to assume counterclockwise. So here's what we're going to do. We're going to use our coordinate notation. So x, y, our original pre-image coordinates, they're going to map onto. When we rotate 90 degrees, remember we said the x and the y need to trade positions. So the x will go second, the y will go first. And since we're going counterclockwise, that's a left-hand turn as opposed to a right-hand turn. Since we're going left, it's this left-hand coordinate that becomes opposite. So in this case, all the y's need to be opposite. So I'm going to write P prime, Q prime, and R prime. And I'm going to get all of those coordinates written down as an ordered pair before I do the actual drawing. And notice, since we are going 90 degrees counterclockwise, 90 degrees is one quadrant away. We should go over here into quadrant 2. So just heads up. You should have some idea of where you're going to end up by the end of it. So notice 1 and 1 will trade places. So 1 and 1, not a lot of difference there. And then our y becomes opposite. So instead of a positive 1, I'll make it opposite to a negative 1. All right, let's try Q. 4 and 5 need to trade places. So 5 comes first, 4 goes second. And then that y coordinate is made opposite. So -5. And then last but not least, 5 and 1 need to trade places, so we'll write it as 1 and 5. And then again, that y needs to be made opposite, so -1. Cool. All right, well, let's graph that and see where we end up. So P is at -1, 1, so -1, 1. So there is P prime. That looks good. Q is at -5. So let's see here. 1, 2, 3, 4, 5. And then up 1, 2, 3, 4. So there is Q prime. And then R is at -1. And then 1, 2, 3, 4, 5. And there is R prime. Cool. Now all we got to do is play connect the dots. And we are home free. And again, rotations are just like translations and reflections in that they are an isometry. We should get the exact same size, the exact same shape. The only difference is the orientation. Notice in this case, Q is pointed up, whereas here Q prime is pointed to the left. It's just how it's been turned is different. But again, same size, same shape, we're good to go. Again, I strongly recommend that you bring a compass and a protractor with you to class as we go over these. If you don't have one, I can supply a few of you extras, but I don't have necessarily enough for everyone in the room. So again, bring them with you so that way you can do these well. If you have any questions or concerns, write them down, bring them with you to class, and we'll deal with it. All right, have a good day, folks.